Lesson 16 is graphing quadratic functions from the vertex form. We've seen a little of the vertex form from earlier lessons. It's also written right here in the aim. You'll be able to graph quadratic functions of the form. And don't worry, I'm not going to have you actually make your own graph paper or get graph paper at home. For this assignment, you guys are going to listen. You're going to take notes on the instruction on the pages of this lesson. And then I'm going to have you do a little inquiry activity where you're going to go on to geogebra.com, and I've used it in some of my lessons. And you guys are going to make graphs for me, but I'll explain that at the end, and it's also explained in the instructions for the assignment. So again, you're just following along with me as if you were in class and we're taking notes together. We're going to look at, so the do now, all these are done for you. We're kind of just walking through it. You're copying. The do now you don't have to copy. I'm not going to make you graph all of these, but let's just look at it together. So we graphed the functions on a specific domain. Remember, domain is our x values from -3 to 3. And they all have a squared value. If we look up here, right, x squared is kind of is a quadratic. This is also, they're all quadratics. Some of them are just factored. Some of them aren't in the standard form. So we're just kind of seeing what's happening here. And again, remember, when you have a quadratic, we're looking for that pattern. So you see the 9, 4, 1, 0, 1, 4, 9. You're looking for that symmetry. The vertex is that turning point. So here, if we look at the first one, the blue, the turning point is 0, 0, because that's where the pattern repeats itself. Let's just see the red. Where's the turning point? It's at 2, 0, right here, right? Because then it goes to 1, 1, 4, 4, 9, 9. And the vertex for this one is -2, 0, because then it goes this way. But I squared this off because we were only looking at those values, so those were the ones you plotted. But don't worry, I'm not going to have you do it by hand for this. And we're using technology, so why not, go through a technological way. So for these, you can just write down the equations. We're going to just talk about how to find the vertex from the equation again. So vertex form is on the top. It was x minus h squared plus k. I would probably write this down for your notes. Whoa. This formula right here, generally the vertex form. So if we go to our exercises here, without graphing, we can state the vertex if it's in this form. And remember, we're taking the opposite that's in the inside the parentheses, and we're just taking the value on the outside. So if it's x minus 5 inside, it's just going to be a positive 5 for the x value of the vertex and 3 for the y value of the vertex. So vertex form stems from when we did completing the square. When we factored using completing the square, I had you guys solve it to look like this. Then I had you equal to 0. Then I had you find the solutions. So it all really connects. Right now we're finding just the vertex. What is that turning point of the graph? And you do have your calculator. You can graph these to make sure you're correct. But this is just a point to tell you that you can find the vertex without actually graphing it. So for number 2, we have just an x squared. There's no parentheses, so then it's technically x plus 0 squared. So 0 is the x value of the vertex, and then the number outside is the y value, so -2.5. And number 3, again, you're just taking notes. Write the original, write the vertex, so you have it in your notes. We will be going back and reviewing, having projects and quizzes on this stuff, so don't think you're just completing this because you need a grade, right? I will be testing you in May, mini quizzes and stuff. So, but you do have online resources to help you. Again, x plus 4 squared, so take the opposite, -4, and since there's no number outside, it would just be 0. Okay, so that was just finding the vertex. We did see some of these previous lessons. This one says write a quadratic equation whose graph will have the given vertex. So we have now I'm giving you the vertex. Now you're kind of just plugging it into the original formula to set up the equation. So remember the original this is the original, y equals x minus h squared plus k. So if I give you, what was the first one? 1.9, negative 4. All right, so all you're doing is plugging this in. So this is your x, and this is your h. So we use h and k now for our center. This is h, and this is k. So now my new one is going to be y equals x minus h. H is 1.9. So minus 1.9 squared. And then it's going to be just minus 4. So the reason why we take the opposite in the parentheses is because, look here, when I plug in a positive 1.9, it looks negative, right? Because it's subtraction. So that's why when you state the vertex, you have to switch the sign technically. So, because we plugged in a positive 1.9. Hopefully you see that. You can email me if you have a question. But that's why that's why I say take the opposite when you're stating the vertex, because since there's a subtraction sign. Okay, we wouldn't have to take the opposite if it was x plus h. The signs don't change. But since we do have subtraction, the sign's changing. All right, next one. I'm giving you the vertex. Again, you're plugging 0 and 100 in to the original formula to get that quadratic equation. And the same thing for this one. So negative 2, take the when you plug it in for number 2 or number 3, you can just state the opposite, but remember, this is subtraction. So if we're talking about a negative 2, if I plug in, sorry, this looks a mess. If our point is negative 2, 3/2. Negative 2, 3/2. This is the point we're plugging in. So think about it. If we're plugging this in, we're going to get x minus a negative 2 squared plus 3/2. Well, I don't want to leave it as a minus and negative. What's minus and negative actually? Just plus 2, like a positive. Turns positive. Those are the rules. So that's why, again, why also it kind of looks like we take the opposite, right? This is a minus 2. This is a negative 2. But in the equation, it turns plus 2 because of that subtraction sign. Okay, so you're just taking notes on those. Now we're on page 4. Find the vertex of this. So the vertex, again, this is just for you to remember the h value, even though sometimes it doesn't have to be h and k. It can be a, b, it can be other letters. So just know that the x value of the vertex, so that a value, is inside the parentheses. If it's a minus a, it's going to be a plus a. And then if it's a minus b, it's going to keep a minus b. This one on number 2 says write the quadratic in vertex form, then find the vertex and graph the function. You won't have to graph it, but remember this one, when you want to put it in vertex form, you complete the square. So let's do it together. We have x squared plus 6x plus 13. I know the work's done here, but in case you forgot, x squared plus, I forgot what it was, x squared plus 6x. So we're going to use complete the square process to get it into this vertex form. That is the only way to get into vertex form. So complete the square. And remember, we want to move this guy over because we want to complete the square with these two terms. So remember, we take this b value, we do b, what do? Divide it by 2, and then you square it. So our perfect square now is 9. We're going to add this 9 up here. And then remember, if we're adding a 9 to the left, we gotta, what to the right? Subtract it. So now we have x squared plus 6x plus 9 plus 13 minus 9. Remember, it's an expression, so we need to balance it by making that 0 value. We can't just add a 9 to an equation. That doesn't make sense. Okay? And now we factor our trinomial, our perfect square trinomial, remember? perfect square trinomial. And you can take my notes that I'm doing here, or you can take the notes on the PDF. It's whatever you want, but I'm just walking through it. So remember, two numbers that multiply to 9 and add to 6, right, is x plus 3 both times. So this is x plus 3 squared. It's also the number that we used here. Remember, it's the same one. And then we simplify these two. 13 minus 9 is just plus 4. So now we have vertex form. So my vertex from this equation is going to be these two numbers, right? Take the opposite of the inside, and then you take the outside number. So negative 3, 4 is our vertex for this problem. Okay, and then it says, are there any roots? So if we did solve it, and you can see it here, if I set it equal to 0, remember you can solve for x. That's what we practiced this a few lessons ago, probably a few weeks ago by now because of the pace we're doing with the lesson. But whenever you set an equation equal to 0, you're solving for x, which is the roots, right? It's the solutions. And what happens when we try to solve for x? We move the 4 over, it turns negative. And then to get rid of that square, the rate power of 2, we have the square root both sides, but can you square root a negative 4? We just learned that if your radical is a negative, you can't do it. It's not mathematical. So there are actually no real roots for this, and you can also graph this in your calculator. I'm going to show you this later as well, but if you type in, which this is part of your assignment today, so you can leave GeoGebra open, but go to geogebra.org, geogebra.org. It's like the free graphing calculator app. I don't know, some of you may be using it, but you can always use this as a good visual. And even if I put this in, y equals x squared, and do the square to use the caret symbol on the calculator, plus 13, try to zoom out and find it. Is it crossing the x-axis at all? Nope, it never will, so there are no real roots. And the vertex is pretty inaccurate, negative 3, 4. And it actually tells you. It should when you click it. My computer's just being weird. If you click different points, it should tell you. But all right. So we did that one. And you don't have to graph it yourself. You're just going to explore yourself. And then last one, find the vertex and the roots of this equation. So remember, with completing the square, we want to factor out, we want it to look in the standard form. We want it to be x squared plus bx plus c. So that's why I factored out that 3. Let me just look for a second. Yep, so this is the last one we're going to do together. Okay? So we have y equals, and I have the work here, but let's talk through it. 3x squared minus 30x plus 2. 3x squared, bad memory, minus 30x. Okay. So again, we're completing the square because we want it in vertex form in order to find the vertex. There's a lot of ways to find the vertex, right? You can graph it. You can, or you can do it this way, but I want to see you guys take notes on this way so that you guys understand. So we want it looking in standard form. So we're going to factor out only out of these two first terms a 3. And I'm just going to erase this for now so it doesn't get in my way. So I'm going to pull out a 3 from both because they have a 3 in common. So 3 goes on the outside. I just get x squared minus 10x. Remember, leave a space because we want to complete the square. Plus 2, and then leave a space over here because we have to still balance it. Okay, so this is from prior lessons. So hopefully this is coming back to you. We take the middle term. We're completing the square, so we take negative 10. We divide it by 2, which we get negative 5. And then when do we do a negative 5? We square it to get a positive 25. So then what do you do with this number? Where does it go? Here. And then what goes here is what we have to think of. So you're almost right with the 25, but what else? Because what's happening to this 25 inside the parentheses? We're not just adding a 25, we're actually adding a 3 times 25. Do you see how this is like being distributed into all of these? So we actually have to put not minus 25. We're going to actually put minus 75 because 25 times 3 is 75. So again, I'll just explain that. You took out the GCF, but if you're adding a value inside this parentheses, you have to remember that this 3 is being multiplied in originally. So we're not minusing a 25 to balance it, right? To make that 0 number, because you can't just add the 25 into an equation. You have to subtract it from somewhere else as if like it would never happen. It's going to be 75 because of that dangling 3, that GCF. All right, so now let me rewrite this so it looks a little neater. So we have 3 times x squared minus 10x plus 25. And I'm just going to simplify this. 2 minus 75 is minus 73. All right, remember we want to factor this trinomial. That's the whole point. And remember, it's always the number that you square. So this simplifies to x minus 5 squared. And you can also solve it, right? What two numbers multiply to 25? That also adds to negative 10, right? And they have to be the same. Negative 5 works. Leave the 3. Leave the 73. So now what is your vertex? You have this in vertex form now. You have your x minus h, and you have your k. So your vertex is this number, but take the opposite, right? So it's 5 and then negative 73. So that's a big one that goes really far down. And you can pause it if you need to take notes still, but I just want to make sure we got it right. So, this looks shorter, obviously, than my work, but I showed you all the steps. And again, email me if you want to go through it more explicitly, but this is where our notes stop. So page 5. This is just a summary of the notes. If you want to put this in your notebook, this would be a nice little conclusion to our lesson. And this thing is blank, so that could be the last thing you guys write in your notebook. And the last thing I want you to submit, so you're going to submit a copy of your notes. You can type them you're doing math on them, so you can handwrite them, type them, whatever you guys usually do. But then I want you to also explore GeoGebra, the website I just showed you, so this one right here. And I want you to create your own equations. I want you to make 3 of them. So I want you to make one that has no solutions, like this one. I want you to make one that has 2 solutions, so it crosses the x-axis twice. And I want you to make one that crosses the x-axis once. So, I'll give you some help here. So x squared plus 5x, that is a quadratic. And it does cross 2 times, right? It actually crosses nicely. It crosses at these roots. And if you do click on it, I don't know why mine's not working. It will tell you the roots, but ooh, look, there's so many different things to play with on here. Yeah, just explore it. But I want to see 3 graphs. Try to get 3 that, that are the ones we've learned about that are different than the ones I'm showing you now. And then what you're going to do is make sure they're in color. So you see how there's colors here. Make sure they all have a color. And you're just going to take a picture or a screenshot of your screen to show me that you did explore GeoGebra. And that's really it. If if you're struggling, you can show me other lines. So, here's a linear line. If you want to make an exponent, you hit, let's say if I want to make an exponential, you hit the number or whatever. If you want to make an exponent, you hit shift and then the number 6 has a little caret symbol. And then you can, put whatever there. Or also there's the squared buttons here, the exponent buttons here. So you don't really have to do that. You can play around with these. There's numbers, the keyboard. If the keyboard doesn't show up for you, you hit this like keyboard button down here will probably work. And it'll pop up in case you can't find it. But yep, you're going to submit a screenshot of the 3 graphs I want to see, just so I know you've explored this. It's a really cool tool, really helpful. And yeah, hope everything's good. Email me if you have any questions. You guys are doing great.